Congratulations.
Okay, so what did you guys observe?
Make it stop, make it pop.
But wait, before it popped, what happened to the soap film?
It was rising like a bubble.
So it went up, right? You saw, so what happened to the volume of air underneath the soap bubble?
It got warmer. It started more energy.
The
The volume. It gained more energy, so the particles started moving faster.
Okay, so we're going to try to explain what happened again in terms of collisions, right? The soap film is not strong enough to hold very much pressure, right? So it's going to move based on the changes that happen when you place your hands on the outside of the can. You need to explain, you first need to explain your observation, what happened, and then you have to explain why it happened. Over there. Then you have to explain why it happened.
Bye-bye.
Okay? All right, let's go.
I have a theory. Let's go for it. Okay, don't record me yet here. What I have to say. Alright, so when you warm your hands, your air, friction in your hand is causing heat, right? So when you put your hand on
What's heat?
Mick Savage.
What's heat? What kind? Okay, and then what happens? Then you put it on the outside of the
and then you put it outside the can, heat transfers.
No, the friction's done.
Heat transfers into the can because for like for sense of equilibrium, so it takes the heat from your hands.
Which has more friction?
Is it metal conductor?
And then what happens?
And so as the energy is transferred in there, the particles gain more energy. They
Which particles?
The straight lines.
Okay, good. So write that down.
Straight line particles. What?
I saw first. I saw. You then saw when
Straight line collisions.
What do you think? First of all, what is heat? What is if the particle's moving faster, it has more energy. So if it has more energy.
What happened? This is the one of the questions.
Hold on, I'm going to record your answers then. Your questions. I'm sorry. You guys have a theory?
I have a question.
Uh-huh.
Would the outcome be any different if this can was made of a different metal?
The speed of it might be different because aluminum is a very good conductor of
Heat.
heat. And what is heat?
It's how fast.
No, what kind of energy is heat?
Oh, isn't it connected?
Kinetic energy. And what is kinetic energy?
The energy of moving.
Of motion,
Yeah.
right? So now in terms, we're looking at the particles of gas. So now explain what happened.
The heat from our hand went on the aluminum and caused that to move faster, and then it bumped in the particles inside the can, and that moved faster, and then it started rising up, and then the bubble started
Why?
going.
Why did the bubble move up?
Because the air is moving faster now, so
Okay, so explain
it
that.
needs to escape.
Explain it. We're doing stuff. You're gonna have to wait. What else? You guys, what did you decide?
Well, I think like the heat, like because your hand was in the heat, I think it's like it pushed the air that was inside the can to like inflate the bubble.
But why?
Friction.
The friction was how you heated your hand.
Okay, so
Then you put your hands on the can. What happened to the can?
It got like warmer.
Because?
I don't know.
Because there's more what kind of energy?
Kinetic.
Okay. Then what happened to the gas particles inside the can?
Up.
But why?
Cause
What happens to the motion of the particles?
they get like more space between.
But why?
Cause I don't even know. I'm not.
First, did you change the can? Did you make when you put your hands on the can? That's a change, right?
Right. I think it made the can warmer.
And then?
I think it pushed the particles up.
No, but you have to explain it in terms of motion. What happened to if we're thinking about kinetic energy, what happened to the kinetic energy of the gas inside the can?
It increased
Which makes the particles move?
Moved upward.
Not upward.
Down?
They're going to move in. They're moving in all directions. Remember, they're random.
Oh yeah. So
Yeah, because
So, are they moving any differently from before?
yeah.
that makes sense.
How?
Because like, you know,
Moving faster.
They have more energy. They're moving faster. Does that explain what happens to the film? Okay, write that down. Discuss it and write it down. Are we decided what happened?
Is it heat like vibration?
You said what? Heat is what?
Is it vibration of?
Right. Well, the metal in the can vibrates because it's locked in place. But what happens to the gas inside the can?
Does it increase?
It increases in what?
Temperature? No. What am I saying?
Well, yeah, but in terms of motion, how is the motion different?
I think like kinetic energy, like made
Yo, I did talk.
air pressure, it affected the air pressure.
Yeah, but how? Why? What is kinetic energy, first of all?
Kinetic energy.
It's what?
It's the average movement of particles.
Okay, so what's happening to the motion of the particles?
Okay, so when the heat was transferred, the movement of particles increased and the pressure increased. So the bubble,
The pressure is a result of the particles moving
particles
faster.
moving faster
And
because
so then what happens to the film?
it blew.
Pushed up,
Yeah,
right?
pushed up.
Okay, so write that down. You guys have an explanation?
Yes, they do. Okay. No, stop. It's my moment. Okay, so the heat from our hands caused the particles inside the can to excite and rise. And these
Wait. Inside the can?
Yeah.
Talking about the gas.
Yeah. So it was getting excited from the heat because,
Excited, what does that mean?
like, kinetic energy was rising,
What's
was moving.
kinetic energy?
Energy that moves.
Okay, energy of motion.
Yeah.
So what happened to the motion of the particles?
It was moving faster and faster and it started to rise.
No, they're
was-
moving in random motion, right?
Yeah.
So it's not rising,
It's just moving everywhere.
right?
Yeah.
And so what
And-
was it that you observed on the can?
So the bubble was in the can. A bubble was forming, but then it popped, and this is because the particles of anything was colliding against the bubble. But the bubble, unlike the balloon, was not able to handle the constant collision of the particles. Therefore, it popped.
Okay, so it moved. It went up.
Yeah.
So the volume inside the can, the volume underneath the film,
Yeah.
changed that.
Well, it was increasing because.
Okay. All right. So write that down. Got it?
What? We have
Correct. No, not apples. They speed up, and that means they're hotter.
There's a sub for Steve-O.
Increasing the pressure in the can.
Well, it's not the pressure. All you have to increase is the speed. How fast are the particles? So then the yes.
I'll come through your next class.
Okay. Guys, we're gonna do it again. But this time, we're gonna use ice.
Whoa.
Right? So we're gonna use ice
Wait for this.
to cool the can.
Oh. Oh, I was wondering what that was.
No. Yeah. All right, so here we go. So now what we're going to do is we're going to do